Right, just have a look at the TyCAD version 1 CAD functions. Although it's not a graphical application, I'm going to do it through the Raspberry Pi Start X Windows Raspbian Flavor graphical user interface, because we can use applications like LibreCAD, and it's got a nice C editor called Genie, which is actually quite nice, especially for a beginner. So download the software, put it in a folder in your home directory. So for instance, mine's in CD, myc, ls for list of files, CD, TyCAD version 1, ls. So what you'll see as it comes, there's some source files, C files, the readme file, which gives you more help, input folder, output folder. There's already some files in the input folder, data files to do with mapping data and things like that, which so the program picks up them straight away. There's a make file there, so in order to compile you may have to change the permissions. I don't know how it's going to come when it downloads to your machine, or whether you've got permission to run it, but there's no executable there, so you've got to compile it and use the make file. So you just type make. It's going to use GNU C compiler on this machine anyway. It will do on all Raspberry Pis, pretty sure. Hopefully that'll be successful. You can see it's using some checking, standard C99 compiler, linking the math. If you don't know much about C, it's all a big learning curve, but you know, it's not the hardest language in the world. It's one of the best, of course. So if I go ls now, you'll see all the object files and the executable files. The executable file is called TyCADv1. So to run that, you just go ./TyCADv1 return. Brings up a very simple point and shoot graphical. It's just a menu system, so you can see what the features of the functions are really. So for instance, there's 0 through to 12. Let's go through them all one by one. So you press 0, enter. Basically that's printing out a DXF file. You might not be interested in looking at the numbers. So to run the program again, press the up arrow, ./TyCADv1. You're just running it again. It's not very elegant. I should have looped it really in a more sophisticated system. So if we press 1 now, return, it says UK Mac example exported to the output directory. Okay, so output is one further directory, so you go CD output and you go ls. It shows you've got a DXF file there. I've pre-installed LibreCAD on the Raspberry Pi. That is one reason I don't need a graphical front end, but I'm using LibreCAD on Linux and Raspberry Pi and TurboCAD on Windows, just to check that they work. So all you do is you type LibreCAD if it's in your path, which it will be if you just did the standard install, and the name of the file, enter. There's a few warnings, but that's from LibreCAD. And zoom extents. There you can see that's my grid. I'll turn off the LibreCAD grid. That's the Ordnance Survey grid. Now you scroll in and out with the third mouse wheel at front, and you press down and grab the pan. So that's the UK, Northern Ireland and Southern Ireland. And yeah, it's just a demo to show you how to basically draw polylines and then to put them into a format which you can transfer between machines. So you can go off and print this, do what you need. So this is the actual Ordnance Survey grid, which 6-figure grid reference, 100 kilometers per. Yeah, I believe that's correct. Yeah. These circles represent London and its population. I think it's 8 million. Birmingham, Cardiff, Lincoln, Aberdeen, Glasgow, and the idea is to map certain bits of information, whether it be the spread of the coronavirus or whatever you want to use it for, really. I'm making these tools free so people can hit the ground running and try and solve some problems with this TyCADv1 problem. I mean, epidemiology and mapping and tracking, it's a fascinating field. I wish I was young enough to get into it proper. But I've got a few an old dog, got a few old skills left, but the old mind's a bit dull now. Right, so I'll quit out of LibreCAD. Yeah. I'll run the program up again. Oh, no, I've run LibreCAD again. So what you do, the shortcut on Linux is to press the up arrow key as many times. It goes back through the history of your commands. Just a nice shortcut way. I'm in the wrong directory. CD ... go back. Right, here we go. So again, to a DXF of a Nightingale Fibonacci example, or the file is on 3. So press 3. I'll run the program up again. I think I'll go through all these. So a Nightingale example.dxf 5. Generate HTML table for COVID data with a Nightingale pie chart. Press 6. Enter. Generate a GNU script SIR example. To get the data, you press 9. The data, so we press 9. Basically runs through some initial starting points through the SIR model, and Runge cutter or Runge cutter goes through it all and calculates susceptibles, infected and recovered. And pretty shocking results. And run it up again. I'm also fascinated with doing not just the UK coastline, but we've got a model of the world. A more modern interpretation would be WGS84, and I think there are even a lot more newer types of datums and stuff now, but I've gone back to George Airy 1830 Ordnance Survey. Meridian goes through Greenwich, London. I don't know, I like that history. So 10, 11 to generate the file. It's quite a big file, with it being the whole world. 12, MEMS device. Right, so the idea of all this is that I'm supposed to be teaching people how to use CAD. Now, when you're designing, let's get the file made. When you're designing, you don't want a lot of it takes forever to. You come up with one design, you always have to change it 6 times, revise it. And if it's finicky little beams and you've got to calculate the area and the mass and everything every time, you want a computer program to do it. Now you can spend thousands on parametric CAD, or you can just write 5 lines of computer code and generate it all yourself and transfer it in via DXF. I know what I would do. Yeah. Right, CD output ls. So you'll see we've created all those output files now. So that's all the software does, creates output files. For instance, let's have a look at the SIR data. So if we go cat SIR.dat, it's just a comma separated file which we can use a GNU script to plot that out as a graph. In fact, I'll show you how to do that now. So, well, one benefit of using graphical interfaces, you can use a cheat and use this file manager type application. So we go to my C, TyCADv1 output, and I'm just going to go up to the README. It's in the README. Open it in the text editor. You'll see there's a script here that we can use to plot that graph. So I've already installed GNU plot onto the Raspberry Pi. Sudo apt install GNU plot. Straightforward. I'm just going to copy that to my clipboard and go back here. I'm already in the output folder where the SIR data is, so I'm going to type GNU plot, GNU plot. Comes to a GNU plot prompt. Now I'm going to paste in that script, and then what it'll do is run the script. It plots the graph. So the susceptible rate is the whole population. The infected rate starts to increase. Now this starts with just one person. And the recovered rate is the green. And then so the infected rate drops. So that, I haven't got a title block on here, but that's probably the settings where there's aggressive social distancing social distancing has been applied. So the pink line is the infected and the recovered, and then yeah, it peaks there. Yeah, but yeah, look up all the latest stuff on SIR models and play about with it until if you think it's going to be of any use for you, to come up with a strategy. Basically you want to get the R as low as possible, and how can you fit that into the model to achieve that. Now whether that means isolating all the 70-year-olds, I mean, you could argue that only 5-year-olds go back on a Monday, 6-year-olds go back on a Tuesday. Just don't let them mix. But the only problem with this disease is you take it home, you'll pass it to friends, relatives and neighbours, and you will be directly killing somebody. It's absolutely alarming. It's one thing taking risk on your own back, but you can't go home and kill your neighbour. It's dangerous. So to get out of GNU plot, go exit. Right, let's go back, look at some of the other files. Right, so we've looked at the UK map example. Let's have a look at the while I'm in the text editor here, the case fatality table. Basically, I use this on my web page. It just goes through the input file of deaths over cases and comes up with a percentage of what they call the case fatality rate, and that's all on my website, because that's updated every day by the government. The numbers don't mean a lot, but when this is all said and done, I mean, most diseases like SARS, I believe, is around about 3%, and then you scale that up to the number of people in your population. Now at the moment it's running at 10-15%. If you scale that up, it's absolutely devastating. You're talking 500,000, 1 million people, if the model proves to be correct. Of course, it changes every day because all sorts of weird and wonderful things are happening. Right, so let's have a look now at the Fibonacci example. I got interested in Fibonacci because it explains the growth of population, like rabbits. It's a very interesting model, and nature tends to use it for some reason, whether it be, you know, the growing of sunflowers, or it's very, very so zoom all, take the TyCAD grid off. So 1 1 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 2 is 7, and so on, and then it spirals out like that. Now Fibonacci found this progression, and yeah, I say it's absolutely fascinating. So, and I've drawn it as like a Florence Nightingale pie chart graph. So when you look at the source code, you'll be able to draw these whatever colour you want, whatever degree of a circle you want, and whatever radius you want. So you can generate Florence Nightingale data. She's the woman credited with saving more lives than the actual Crimean War killed in action. She realised that it was the disease, dysentery, infection that was killing people, not the war. Of course, it's 200 years anniversary of her soon. One of the greatest ever British Great Britons. Right. So I naturally thought, I heard her on the radio, but I thought, right, I've got to go back to history, learn a bit, because we learn more about history from history than we do getting a modern GCSE textbook out. So we go to the Nightingale example. So I'm using that data that we generated, the case fatality rate. Open up in LibreCAD. Zoom extents. Of course, you can print this, dimension it up, put more details on, do what you need, or modify the source code to do what you need. But this is the month of May, so there'll be 31 days in May. So I've divided it up, 360 divided by 31, whatever that is, 12ish. And I put the day-by-day case fatality rate, which is the one jumping about, and then the case fatality rate is fairly flat, which should mean that the R in general is 1, but it's highly skewed with care home deaths, city deaths compared to rural areas. I mean, it's horrible because the rural areas, there isn't any disease, and the lockdown. Also, rural areas don't register deaths in their own authority. When you die, these are hospital deaths, you're in a hospital in a different authority, whether that be Lincoln or Grimsby, if you live in the East Coast. And that means you're not going to get registered. It's not going to look right for all them boffins in London who think everything's okie dokie in Lincolnshire. It maybe isn't. So they're smarter than me, so they know what they're doing, I hope. Right, close that. Right, and the last one, is it? Yeah, the Area 1830. This is really fascinating. Oh, I've opened it as a text file. You see, that's all a DXF file is. A series of paired up commands. It looks complicated, but it's more of a faff than it is complexity. So I want to open it as LibreCAD, the DXF file. Zoom extents, turn off that grid. Right, this is the equator, and that's the circumference of the Earth. It's more of an oblate ellipsoid, isn't it? And this is the meridian, which passes through Greenwich, London. The longitude of 0, latitude of 0. 10 degrees latitude, 20, 30, 40, nearly 50 at the bottom, nearly 60 at the top of the UK. So scroll into I'm going to put the whole world on here. The datum's heavily skewed towards Britain, of course, and I think that's why it's shaped the way it is, but I'm not 100% sure. I haven't made a mistake. You check my maths. Right, so this is the Ordnance Survey false origin. They just made it, the grid fit the coastline really. That's the true origin. And this is the meridian line, which will go straight through Greenwich in London there. Right, things have changed a little bit with satellite mapping, and there's some arguments sometimes on transformation of coordinates and projections. It's a fascinating subject, but it does what I need it to do quickly and cheaply for free. So I'll try and get the whole world printed on here, because this is a worldwide problem. We need to know how it's you know, the amount of air travel from one city to another affects the spread and how quick, because if it happens again, you need to lock down certain regions of the UK super quick, certain age demographics. Yeah, I know they're all moaning at the moment that we can't afford to do it again twice, but what we can afford to do is get it right first time, and know how to shut it down and reopen it up properly. We're going to learn an awful lot, and if we don't, well, we don't deserve to. We deserve a mass extinction. The whole point of being a human being is to use the old grey cells like Poirot. Right, that'll do. I've got to keep working on it, chipping away. It's not first class software, but it's free, and have a play. Do what you need with it.